All right, have you ever seen the HBO show Silicon Valley? If you have, you definitely remember Pied Piper, right? I mean, their whole company was built on this seemingly impossible dream.
So, in the show, these guys create this absolutely unbelievable compression algorithm. We're talking something that could take huge, massive files and just shrink them down to almost nothing. And here's the kicker, without losing a single bit of quality. Yeah, the whole tech world in the show, they called it impossible, pure fantasy.
Well, what if I told you that fantasy might be a lot closer to reality than any of us thought? Because Google just pulled off something very, very similar, but they did it for the world of AI. And to really get just how big of a deal this is, we've got to talk about AI's single biggest headache.
So, let's dive in. Before we can even begin to appreciate what Google's cooked up, we first have to wrap our heads around this huge memory problem that pretty much all modern AIs are struggling with.
Okay, so when you're chatting with an AI, right, like ChatGPT or Gemini, it has to hold the entire conversation in its short-term memory. The technical term for this is the KV cache. The easiest way to think about it is like a giant whiteboard. Every single word you type and every response the AI gives back, it all gets written down on that board.
But here's the problem. That whiteboard has limited space, and in the AI world, that space is incredibly expensive GPU memory. This is the bottleneck. It's the reason why chatbots sometimes seem to forget what you talked about at the start of a long conversation. It's why it costs a fortune to run these things, and why asking an AI to analyze a huge document can feel like it takes an eternity. The AI isn't dumb, it's literally just running out of room to think.
So, what if? What if you could give that AI a much bigger whiteboard, but without having to buy a more expensive one? Well, that's exactly where Google's new solution comes into play.
So, rewind to March 24th, 2026. Google Research kind of quietly drops this research paper for a brand new technique they're calling TurboQuant. And honestly, the claims they made were just staggering. What they claimed was that they could compress that AI whiteboard, that KV cache, without cutting any corners. See, most compression we know is lossy. Think about saving a photo as a low-quality JPEG. Sure, the file gets smaller, but the picture gets all blurry and pixelated. TurboQuant, on the other hand, is lossless. It's like making the file smaller while the photo stays absolutely pixel-perfect, perfectly crisp.
And just how much smaller are we talking? A staggering 6 times. 6x. They can compress that vital KV cache by a factor of 6. I mean, that's like being able to fit 6 full pages of notes onto a single page without even having to shrink the text. It's wild.
And as if that wasn't already mind-blowing enough, it also makes the whole process faster. We're talking up to 8 times faster on modern GPUs. So you're not just saving a massive amount of space, you're also operating at absolutely incredible speeds.
But here it is, the most crucial part of all, how it does this. It's with zero, none, zilch loss in the AI's accuracy. This is it. This is the holy grail that everybody in the field thought was impossible. You get massive compression, you get massive speedups, and there is absolutely no downside. So, how on earth did they pull this off? Let's take a quick peek under the hood, shall we? The method is actually surprisingly elegant. It really just boils down to a super clever 2-step trick.
Okay, step 1. There's a process called PolarQuant, and what it does is it reorganizes all the data. The best analogy is tidying a messy room. You haven't actually thrown anything away, but suddenly everything takes up way less space. Then, step 2, a really clever little error checker called QJL comes in and corrects any tiny leftover errors from that first step, and it does this using just one single extra bit of data. You put those two together and bam, you've got near-perfect lossless compression.
Okay, so the tech is obviously super clever. But what does this actually mean for AI, for us? This, my friends, is where it gets really, really exciting. Let's talk about the real-world impact.
Get this, for the exact same cost, running on the exact same hardware, an AI can now handle a conversation or a document that is 6 times longer. Just think about that for a second. Analyzing a massive code base, chewing through a lengthy legal contract, or even an entire research book. Tasks that were just flat out impossible before are suddenly within reach.
So this single breakthrough, it unlocks 3 huge possibilities. 1, you can make AI 6 times cheaper to run. 2, you can make it 8 times faster. Or 3, and this one might be the biggest game changer of all, you could finally run a powerful long-context AI directly on your phone, no more needing to connect to some massive server in the cloud.
And you better believe the industry is already taking notice. The CEO of Cloudflare actually called this Google's DeepSeek moment. Now, he's referring to another company that completely shocked the world by building a top-tier AI model for just a fraction of the usual cost. The theme here is exactly the same. It's a massive leap in efficiency that completely levels the playing field. So let's bring it back home. Why does this matter to you? Well, first off, the AI apps you use every day are about to get cheaper and way more powerful. Second, for all the developers and builders out there, that memory wall you always hit, it just got pushed 6 times further away. And third, and this is huge, this empowers startups and smaller companies to actually compete with the giants, letting them build powerful AI without needing a giant's budget.
Now, let's manage expectations a bit. This technology isn't everywhere just yet. The research paper is out, which is a huge first step, and we're expecting the official widespread release from Google sometime around mid-2026. But even so, the community is already buzzing, people are already building on these incredible ideas.
Which brings us right back to where we started. That original question, a technology that can make the impossibly large small without losing a single drop of quality. I know, it sounds exactly like the plot of a TV show. But now, it's real. And that leaves us with just one question, really. What are we going to build with it?